So yeah, that about the design. So if we go back to this picture, now we have the data here. The owner can access, owner can look, owner can comment, and this kind of stuff. And then if we go here to the construction, what the actual contractor or the people in the construction site can do with these models. First of all, what I was also telling already, they can have tablets. It's also very useful nowadays. A lot still you see people with the big drawings walking around the construction site. When it's a bit rainy like this, they don't do anything with the drawings. Then you figure out, yeah, I forgot my drawing of this road. I have to drive back to the wherever the drawings are, and then drive back. So there's a lot of driving to picking up the information. So this is the tool that you can have all your information, all the data in the model with you in your, you have to have a big pocket, but in your hand, for example. So everything is accessible, not only nice pictures, also the information about the things. And this is how I will show it soon live. So this is the tablet interface. This red dot over here, that's important thing. That's your where you're standing. That's a place where you stand at the moment. So you have, of course, GPS in your tablet, so you see your position, and you see your position in the cross section, also in the 3D. So you know when you are on the field, here's the road coming, and now it's less and less. At least in Finland, there is not that much of these wooden sticks where the surveyor comes and measures it on the space. When there's machine control involved, there's nothing. There's just field, and you don't know where is what's coming. So this is a good tool to figure out what's coming where, and things like that. And then this is also a good tool to interact. So there is tools for making red markings, so you can mark in the field some places of interest. You can do note text and photographs. So of course the tablet has some camera, so you can take pictures which are then also with GPS located. And then you can make this kind of little yellow note text with the texts to kind of make notes what you found out in the field, which is also quite handy. So how this actually looks, I don't have a tablet with me, but this works also in a computer. So this is the project, the Seinäjoki project. I have it all in my, what they call offline database. So what is also a good thing about this, what we found out even in Finland, there is not internet connection everywhere. So even though our teleoperators are saying what they're saying, but it's not true. So what we have done so-called offline use mode, so you can load everything, all the data from the database to the actual device, so you don't have to worry about is the camera working or not. So this is the data. What I can do with it, of course, I have different views. I have a map view where I have all the lines or whatever I want to see there. Then I have a cross-section view, which is the button on the right up. Then I just pick a middle line which I want to see. So here I get all my surfaces, and since this is a model, this is no picture, this is no DVG, I can just then drag this cross section wherever I want to have it. I go somewhere there. Then I also have, of course, the 3D view. So this is on 3D view. And I can see here that I have my bridge here. Also with me. I can ask the same information as I asked from the, okay, not in this version obviously. But yeah, the idea is that you can use different views. Usually what the users do, they use mostly these two, cross-section and the map. Then of course you can then, this is not, here I have the road models, but if I have also pipes and manholes, so I just push that button to make them visible in all the views. And then once I have them visible, I can then ask about information. So here I have, for example, some manhole, so I can click on the manhole. I can see what manhole that is. Then, if I would have GPS, since we are inside, we don't probably have, but I can show you how it actually works. So we have some simulator here. So I will just quickly show you. So that was my picture. Interesting. This computer just crashed.
No, it's okay.
No idea. Yeah. Great. So, what you were supposed to see is that if you walk around and you have the cross section on, then the cross section walks with you, so you can see all the time where you are.
Turn off Skype.
It's doing things without my acceptance. Yeah, I'll just turn it on again. Or actually turn on only the presentation. Sorry about that.
So machinery.
Yeah. It's just a technology. You never know what it brings to you. So yeah, what I didn't show was to take pictures. Of course, you can take pictures, you can make notes, and those notes then go to the database. When you get out, when you come back to the office, when you're offline, you go back to the office, it synchronizes all the data which you have gathered to the place. Also, for example, if the contractor does those, the designer can see those and things like that. Then another thing where the models are used and where they're actually taking the most out of the models is the machine control. How many of you have never ever heard about machine control? There's one. So machine control, to put it shortly, is the thing that we put GPS or some other types of positioning technology to the machine. It could be excavator, it could be bulldozer, whatever machine they are. And so the machine, for example, for the excavator, the machine knows exactly where it's digging to the 1 centimeter accuracy or to the accuracy what we need. And then we feed to the machine the models from the designer. So the guy in the excavator sees the actual surface where he has to go. That's his goal. And this is, I think, it's big booming of machine control in Finland, and most of the contractors are using it, and more are coming. And what I was talking here also with Trimble people or with SciTech people, it's also coming here a lot. And this, on the other hand, this gives a lot of requirements to the designer, so the project, it's not anymore enough that you have every 20 meters cross sections and you don't care what's between those 20 meters. That's no longer possible because you have to have a continuous model which the machine is then stupidly following. So that's the main challenge here. So the designer has to produce more quality models. They get also maybe paid more or they're not, but the money is coming from the contractor. Contractor has much higher efficiency. The contractor can build much faster and can have much bigger quality of work. So the accuracy what he's working on is much higher than with the normal way of constructing. So this is coming, and there's no way back. That's what we have seen so far. How the models are using, I have here. How the models are used, I have here one simulator. Hopefully it will do. It will cooperate this time. So this is the actual simulator of the computer, what the guy in the excavator or the bulldozer has inside. So what he does he's hooked to the cloud, so Trimble Connect, or its predecessor, what's called Trimble Connected Community. It's similar kind of a cloud, but now this Trimble Connect will replace that one, so we can load directly models from the cloud. This doesn't wants to cooperate. So he loads the model from the cloud, and then the only thing he needs to do is just to drive the machine, and he knows exactly, without any measurements, where he needs to do and where he needs to go. Then there's also a possibility to put on what they say auto mode. So, for example, if you have a bulldozer which has a blade, the driver can put the auto button, so the blade is actually moving itself according to the surface, and the guy, soon it doesn't have to be a guy, I think it's just driving back and forth like a monkey and doing
and stop.
Yeah. So that's his job is after that very, very simple. If I get this on. So here we could see, hopefully. Yeah. So here he will see the. If it would be available, he would see the surface, and he can see the numbers, how much you have to lift the blade if he doesn't have auto mode on. The same with the excavator. So when he's excavating, he sees exactly where this point of an excavator is, and he's then just doing what this box is telling him to do. Then what else can we do with the models in the construction side? Is this mass level optimization. We already heard today that this is the most expensive part of the project in the road and railway. So where do we move masses from which place to which place? And then we have tools to optimize this process. So you have the models again, you bring the models to a tool called Business Center, and then it optimizes to you. You give certain points, you give the point where you can dump excessive mass, you can put the place where you can take the mass if you don't have enough. You can put there some boundaries like rivers and stuff. The program calculates exactly where you have to move dirt, from where to where. You put there what kind of machines you have, how big distance they can follow, or they can deliver. And then of course the follow-up, so then you can see through the internet how the machines are moving. Are they doing it according to the optimization, and how it affects the schedules and things like that. And then very important thing is the quality assurance. So the machines themselves can measure. So in some projects or in some construction, the measurements of the machine is enough to prove the quality. Not always, but in some cases. So they can take points by themselves, and then you can bring those points or lines to the same tool. Actual points, yeah, as built points. So you can bring them to the quadri for the designer, or you can bring them to the connect for the owner, or you can bring them to the digital construction site tool. And then what you are interested in, how far these points are from the designed surface. There are certain tolerances which you have to follow, and then the colors tells you that am I in the tolerance, or then am I not. If I am not, I have to do something. So this is very important information. How this information is collected nowadays, there can be a surveyor, there is a machine, but more and more we see this kind of stuff. So there's a laser scanner, drone, or some other cars by driving. They're doing this kind of point clouds, And here you can see pretty easily with your own eyes where something is wrong. Here, for example, I have this design. This is design surface. This blue one goes over the point cloud, so there is something not done as we were thinking it will be done. I can show you this point cloud actually, maybe in the in Connect, for example, or in Quadri. Or in PowerPoint base, not Quadri. So here you see the point cloud. Turn it on. This point cloud has this was actually done with some backpack. There's some companies delivering backpacks you put on your back, and then you just walk around and then you collect points. This collected 45 million points. And here you can see you have all the models, you have the bridge, you have those are the surfaces, design surfaces, and then here you can pretty easily see how did I construct, what kind of, also with the bridge, so you can see the bridge structures, more or less, how they are done. And then I can compare also, for example, you can see easily what's wrong with the project. For example, this Seinäjoki, they have done this laser scanning every week. They had some drone that was flying over every week, so you can see how the project is proceeding, and also do the quality assurance like this visual way. What else do I have? Yeah, and then the important thing is when we go to the next level from the construction. So we are collecting the as-built data. So to the database we are collecting also the as-built model. So when we are getting the points, the measurements, so I keep on building the as-built model, which is when the construction is done. I have the model which I can then publish or give to the authorities for the maintenance. So far, as we already heard, they don't know what to do with this data, but they have the data for later purposes. Of course, I need to, for example, if I want to have a look in 3 years how my slopes have changed, there's some vegetation and stuff, what do I need to do about them? So that we have the information how it is built, and then I collect the information how it looks now and compare and see what we can do about it.
Or reconstruction, for example.
Yeah.
Roads repairing.
Yeah, if in 30 years when the road is old, we want to rebuild it or make some renovations, so then we have this would be actually initial data for the next project, and then we go again to the construction continuum, and we get a new as-built model. And this one I already heard, so there is a lot of virtual reality now in design and construction, so I think we will see soon in the construction site people walking with strange looking glasses on when using HoloLenses or virtual reality to support. This is pretty cool, the technology we have tried it. So you can kind of create a HoloLens one-to-one of the bridge and look at it like this. It's quite if Ernest has them to next seminar, I really recommend you to try.